Hello everyone. The topic of this chapter is data visualization. You have already learned essential metrics to describe data quantitatively, so you can understand your data by using those metrics. But some properties of data are difficult to be identified only by quantitative values. Data visualization is useful to understand and show the whole picture of data. By the end of this chapter, you will be able to explain the role of data visualization for analyzing and presenting data, and know various visualization methods and how to interpret them. Moreover, suggest the best visualization method depending on the purpose. Suppose we obtain the values of mean, median, mode, standard deviation, first and third quartiles, and IQR. Can you tell me the whole picture of the data? We have two datasets that have these values of metrics. Let's create dot plots for these two datasets. As you can see, these two datasets distributions are different even though they are the same in the metrics. We cannot recognize such a difference only by looking at the metrics. So, data visualization is a useful way to complement our understanding from quantitative metrics. Moreover, visualization enables us to understand the data intuitively. Quantitative metrics can be objective, but sometimes not easy to understand. In many cases, our audiences are not an expert in data analysis, so it is tiresome for them to look at the slides full of various quantitative metrics. Therefore, visualization is an effective way to understand and explain data. We can visualize the distribution of a variable and the relationship between multiple variables. There are many methods for data visualization. That is, there are many types of figures to visualize data. However, we need to choose the most appropriate way to visualize data depending on the variable's type, purpose, and how many variables included in the figure. Some types of figures are appropriate for visualizing continuous variables, and others are better for discrete and categorical variables. Also, some types of figures are appropriate for the distribution of a variable, but not appropriate for visualizing a relationship between variables. In the following sections, we will see popular visualization methods and when and where we should use each method. As the first section, let me show some visualization methods for univariate analysis. This section mainly focuses on analysis for categorical variables. In univariate analysis, we visualize data mainly to see the shape of data distribution and find outliers. There are various methods for visualizing one variable, but they should be used differentiated ways. We need to use different methods depending on whether the variable is categorical or numeric. For a categorical variable, we can use a countplot to visualize data distribution. If we want to visualize the composition ratio for a categorical variable, we can use a pie chart. If we want to see data distribution for a continuous variable, we can use a histogram or a box plot. If we use a time series data, we can use a line plot. Here, discrete variables with small number of value types can be regarded as categorical variable. So, we can use a countplot and a pie chart to visualize a discrete variable, such as a variable with a 7-point integer scale. Discrete variables with large numbers of value, such as a company's sales amount, can be regarded as a continuous variable. So, we can use a histogram, a box plot, and a line plot to visualize such variables. The major focus of a univariate analysis is to see the distribution and summary of data. So, visualization of one variable is performed for the same purpose. The most popular way to visualize one categorical variable is using a bar plot, also called a bar chart. It visualizes the data distribution by showing frequency of each category. A bar plot is also used to display mean or median in bivariate analysis. A bar plot that visualizes frequencies is also called a count plot. So, for clarity, let's call a bar plot that visualizes frequency as a count plot. Suppose we have a dataset that records the number of employees by job categories. Let's visualize this data using a count plot. The structure of a count plot is simple. The horizontal axis represents categories, and each bar represents each category displayed in the horizontal axis. The vertical axis represents frequencies, and the height of each bar represents the frequency of each category. So, the category with the highest bar is the mode. So, we can identify the mode from a count plot. For categorical variables, a mean and a median do not exist. As for a discrete variable, it is usually not easy to identify the mean and the median from a count plot. A count plot can be created for a discrete variable. But if the variable includes many categories or many discrete values, the count plot will be messy. It is difficult for us to compare frequencies between categories or values. In such a case, we should organize the categories or the values into some groups. In the case of a discrete variable with very many kinds of values, we can regard it as a continuous variable and create histogram instead of a count plot. Another common way to visualize categorical data is using a pie chart. Let's visualize data of a company's sales by region. A pie chart represents proportions of data by dividing a circle into some sectors whose angles represent a quantity, usually the percentage of each category proportionally. When we create a pie chart, we should write each category's percentage into each sector to make the percentage readily visible. However, a pie chart is sometimes not so informative. Let's look at this pie chart. We cannot easily identify which category has the highest percentage, which is the second, third, and so on. It is difficult for us to compare sectors' angles, so it is hard for us to rank categories when their proportions are not so widely different. Next, look at this pie chart. This data contains many categories, so the pie chart has a lot of small slices. The smaller the angles are, the more difficult for us to compare them. So it is hard to compare the proportion of the categories. So pie charts are useful only when the data contains only a few categories, or when the categories are widely different in their proportion. One way to improve a complicated pie chart's visibility is to sort the slices clockwise in descending order. However, this pie chart does not have better visibility than a relative frequency table. So, the use of pie charts is useful on only limited occasions, where there are only a few categories and there are wide differences between categories. If the dataset has many categories, it's better to use a count plot, sorting categories by ascending or descending order. Thank you for watching. Please thumbs up and subscribe to my channel.